This is part 3 of section 3.3. We've been talking about dividing polynomials, and what we need to talk about right now is the division algorithm, and we've actually already been talking about it a lot, okay? If f of x and d of x are polynomials and what you're dividing by is not 0, so basically right now we have f of x divided by d of x. And the degree of this is less than or equal to the degree of this. So our top degree is smaller than our bottom degree. And if you look back to the problems we were doing, the top degree and the bottom degree. Okay, so this degree is bigger than this one. Then the q of x is the quotient, and the r of x is the remainder. And what we've been saying all along is that, well, let me kind of show you what this would look like. If I'm dividing by d of x into our f of x, then up here I have my q of x, which is our quotient, and down here we have our r of x, which is our remainder. And what have we been saying all along? To check this, you take this times this, add this, and you should get this, which is exactly what we have right here. In order to check this, which is the part that goes underneath here, then you take what you're dividing by times what you get up here, you add our remainder to it, and it should be the same. That's all this division algorithm is saying. Now, we've also been saying if our remainder is 0, okay, then we say it divides evenly, and they are factors. If it doesn't divide evenly, then they are not factors, okay? And we have also said that our remainder always has a smaller degree than what we are dividing by. So everything in this we have already talked about. Okay. Now what we're going to talk about now is we're going to be talking about some special cases of division. And we have a process called synthetic division. And this is very quick and it's very easy, but it does not work on every kind of division. The only kind of divisions it works for are when you're dividing by something that has a degree of 1 and you do not have a number in front of your x. Okay? So here my degree is 1 and its coefficient is 1. I'm allowed to use synthetic division. On this one, my degree is 1, my coefficient is 1. I am allowed to use synthetic division. Down here, my degree is 1, my coefficient is 1, allowed to use synthetic division. On the previous page, I could have used synthetic division here, but I could not have used it here. Even though the degree is 1, my coefficient is not a 1, I would not be able to use it. And here, my degree is higher than 1, I would not be able to use it. So we still have to know how to use long division, but learning synthetic division is going to be very useful for us. Okay, now how does this work? The way I'm going to show you to write it down is a little bit different than what you're going to see in the book, but the process is exactly the same. Okay, so what are you going to do? The first thing you want to do is you want to look what you're dividing by, and you want to write down this number with the opposite sign. So since this is a plus 3, I'm going to write down a minus 3. And I'm going to put it in a little half box right here. Now what I want to do is I want to come over to what I'm dividing into, this first polynomial. And I want to write down just the coefficients of what I have. I do need to make sure that every term is there and that I didn't skip over anything. So just like with long division, if I skipped over anything, I have to remember to plug in a 0. Okay? But here I have a second power, a first power, and a constant. Everything's there. It's in the right order. So I'm going to write down a 5, a negative 12, and a negative 8. Again, allow yourself some space here. Okay, now I'm going to be writing in this area. So if you're using lined paper, skip a line and draw a line. Okay, now here's the process. I'm just going to bring down this first number, whatever it is. So that becomes a 5. Now take this number and multiply it by this number. 5 times negative 3 is negative 15. So I write down a negative 15 right here. Now I want to add these numbers together. Add. So this becomes negative 27. And we repeat the process. Negative 27 times negative 3 is positive 81. And then you add. Negative 8 plus 81 is 73. So you bring down the first one, you multiply, then you add. Then you multiply and you add. And you keep multiplying and adding until you've finished everything that you have. Now your answer is here, you just have to know how to look for it. Whatever your last number is, this is always the remainder. Okay? And then here, these are your coefficients of what you have left. Okay? And the degree of this is always going to be 1 less than this. So here I have a square, so this is going to be a first power, a degree of 1. This is the constant, and I have an x right here. So your answer is 5x minus 27 plus your remainder, which is 73, over what you were dividing by. Now you don't write the minus 3, you write down the x plus 3. And you have your answer there. Okay? So let's do this one. 5th power, 5, 4. I'm missing a 3rd power here, right? So right in here, I'm going to have a plus 0x cubed, then square, 1st power, constant. Okay, so if I put that plus 0x cubed in there, I should have everything in there. And then I have an x minus 3. I have a 1st power, a degree of 1. My coefficient is 1, so I'm allowed to use synthetic division. This is a minus 3, so I write down a positive 3 and then put it in a half box. Now I'm going to write down all the coefficients of this, making sure I leave myself some space to keep things lined up. So first coefficient of 1, and then a 4, and then a 0, and a negative 3, and a positive 2, and a positive 3. Leave yourself a space to write numbers, and draw yourself a line. Now your first number comes down without a change, and now we are just multiplying and adding, multiplying and adding. 1 times 3 is 3. 4 plus 3 is 7. 7 times 3 is 21. 0 plus 21 is 21. 21 times 3 is 63. 63 plus negative 3 is 60. 60 times 3 is 180. 2 plus 180 is 182. This is why you need to leave yourself space, because sometimes these numbers get quite big. 182 times 3 is 546. 3 plus 546 would be 549, and that is your remainder. Okay, so what is our answer? Well, this starts off with a 5, so this starts off with a 4. This is x to the 4th, and this would be x cubed, x squared, x, and then the constant. So our answer is 1 x to the 4th plus 7 x cubed plus 21 x squared plus 60 x plus 182 plus your remainder, which is 549, over what we were dividing by, which is x minus 3. Okay, so let's try x to the 7th minus 128 divided by x minus 2. Now we have a lot of missing terms here. Okay, So I have to put in something for the 6th power all the way down to the 1st power. Let's look at this. This is x minus 2. It's a degree of 1 with a coefficient of 1. So when I do my synthetic division, this is a minus 2, so I write down a positive 2. Okay, so now let's write down our coefficients here. Well, we start off with a 1, which is our 7th power. Our 6th power is a 0. 5th power is a 0. 4, 3, 2, 1, and then we have a minus 128. Let's double check. 7, 6, 5, 4, 3, 2, 1, constant. Leave yourself a space, draw yourself a line. Okay, first step is you bring down the 1, and we're just going to keep multiplying and adding as we go along. 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. Add 0, 4. Multiply by 2 to get an 8. Add 0 to get an 8. Multiply by 2 to get 16. Add 0 to get 16. Times 2 would be 32. Add 0, 32. Times 2, 64. Add 0, 64. Times 2 is positive 128. Add a negative 128 and you get a 0. So in this case, our remainder is 0. And x minus 2 divides evenly into x to the 7th minus 128. Also, we could say that x minus 2 is a factor of x to the 7th minus 128. Remember, this starts off with a 7th power, so this starts off with a 6th power. This is x to the 6th, and we go all the way down to having a constant. So, what is this answer? It's going to be 1, understood 1, x to the 6th, plus 2x to the 5th, plus 4x to the 4th, plus 8x cubed, plus 16x squared, plus 32x, plus 64. And then if the problem requires that you write the answer, the remainder in there too, it would be plus 0 over x minus 2. And that's just if the particular problem on the homework assignment requires that you put this in. Algebraically, it's not necessary.